Let's start a complete example from start to finish of a linear correlation and also a test for correlation. So the Consumer Price Index, CPI, measures the average change over time in the prices paid by urban consumers for consumer goods and services. The CPI affects nearly all Americans because of the many ways it is used. One of its biggest uses is as a measure of inflation. By providing information about price changes in the nation's economy to government, business, and labor, the CPI helps them to make economic decisions. The President, Congress, and the Federal Reserve Board use the CPI's trends to formulate monetary and fiscal policies. In the following table, X is the year and Y is the CPI. So the horizontal axis will have the year and the vertical axis will have the CPI. It is an index, so we don't have units for it. It goes from a smallest value of 10 in 1915 to a largest value of 166.6. So we are thinking here that we can go, say, in the horizontal axis, start in the 1900s and go by tens, 20, 30, 40, 50, 60, 70, 80, 90, and that will be 2000. And the Y value goes from 10 to 166.6. So maybe we can go from 0 by 30s, 30, 60, 90, 120, 150, and 180. And we want to sketch this by hand. And of course, probably for our exam, but of course we will want to use Excel to see the graph done in Excel. So I have here the year and the CPIs in Excel. I'm gonna insert a dot plot, and there it is. And I'm gonna try to imitate a hand sketch drawing of this. So I sketched the scatter plot, of course, by hand is not as accurate as it would be in Excel. Excel managed to do a much better job. And then the next question is asking us to find the equation of the line of best fit. And I'm gonna right click on the dot and add a trend line, make sure it's linear, display the equation, and display the R squared. So Y hat is 1.6625x minus 3204.4. And the next question is for us to draw the line by hand on the scatter plot that we sketched by hand. And what we want to do is we want to imitate Excel and find out where Excel started from and where Excel ended at so that we can sketch that line. And if you remember, Excel will start at the smallest X value, which is equal to 1915, and it will end at the largest X value, which is 1999. So we want here to find those points. We need the Y hat when X is 1915 and the Y hat when X is 1999. So instead of inputting formulas, I'm just gonna copy the A here and the B that it gave me. Remember, it is negative 3204. And make sure you have it as negative. And I'm going to also input R squared because I asked it to show me R squared. I will need it for my hypothesis test. And for the y hat, I'm going to say this is equal to A, which is here. And remember, I need to always stay at this A location. So I'm going to have it as $138 for the line times X, and my X value is on the same row that I'm calculating the y hat, plus B, and the B is in this location, and again I want to always keep it steady in that row, so I'm going to put a $sign at the row, and that y hat is negative 20.7125. So I need a point that will have a y equal to negative 20 when x is 1915, and then, sorry for that, and then a y equal to 118.9 when x is 1999, which is the year. So the 2 points that I need to show here is 1915 with a y hat of negative 20.7 approximately, and then the 1999 with a y hat of 118.9. The next thing I'm going to do is I'm going to plot those points. So negative 20 will be, let's say, somewhere here for 1915, and the 1999 with 120 almost will be somewhere here. And the next thing I'm going to do is I'm going to draw a straight line that connects these points, and this is approximately my line of best fit. What is the average CPI for the year 1990? This is the y hat for 1990. For x equal 1990. And if we have it, if 1990 is one of our x values, we have already computed this. Otherwise, if it is not one of our x values, we will have to compute it ourselves. So here we will do some predictions, and we will predict for 1990, and we will just copy the y hat formula for the x of 1990 that we have entered there. So that comes out to be 103.975. Ooh. I need to go in my notes. All right, so that was approximately 103.975, and that is the average CPI for 1990 from the line of best fit. Now you can see that it is not a perfect looking fit. Maybe a curve would be a better fit here instead of a straight line, but since we are learning linear regression, we just fit a straight line. We want to interpret the slope of the line of best fit. If you remember, the slope is that the estimated y is expected on average to change as much as the slope for every 1 unit increase in x. So for us, we will say here that the average CPI is estimated to increase 1.66 points for every year that goes by per year. We say that it increases because the slope is a positive 1.66. We want to interpret the y-intercept and check if it is reasonable. The y-intercept is the value negative 3,204.4, and it will be the value, the expected value of y when x is equal to 0. So for our scenario, in year 0, the CPI, the average CPI is expected to be negative 3,204.4, which is not a reasonable value for the consumer index. So why did we find an unreasonable value of the average CPI? And that is because we are extrapolating way too far from the years 1915 to 1999. The next question is for us to find the correlation coefficient and to determine if it is significant. So here we want to do a statistical analysis test, a hypothesis test. First of all, how are we going to find R? R is the correlation coefficient. We will take the square root of R squared, and we will make it positive if the slope of the line is positive, if there is a positive correlation, and negative if it is a negative correlation. Of course, if we have different statistical software, it will first calculate R and then it will square R to give us R squared. But for our purposes here, we will just find R ourselves. So from R squared, we can find R. I'm going to find it up here. And it will be the square root of R squared. Does it have to be positive or negative? Since this slope is positive, 1.66, the R will also be positive. So I found R to be approximately 0.869. The next thing I want to do is I want to do a t-test to determine if this correlation coefficient is significant. So I worked in Excel. I stated my null hypothesis to be that the coefficient of correlation, the correlation coefficient in the population between those two variables is 0 versus the alternative hypothesis that it is not 0. I used the count function to find n in my Excel sheet. So up here I found n using the count function, and then n minus 2 will be the degree of freedoms. The degrees of freedom, so my degrees of freedom will be 12, and then I use the formula in Excel to find the test statistic. It is R times the square root of the degrees of freedom divided by 1 minus R squared. So again, here in Excel, I entered this formula. So it is R times the square root of the degrees of freedom. So I use that n, the 14 minus the 2, and then divide by the square root 1 minus R squared, which is located in one of the cells above the X and the Y data points. So I found the test statistic to be 6.094264. I'm looking for a two-tailed t-test, so I need the p-value for a test statistic like that. So I'm going to find the p-value up here. And I will do that using the t distribution. I want a two-tail, so t.distribution.two-tails. The x is located here. That was my test statistic. And the degrees of freedom are n minus 2. So this is some value located in the 5th decimal place after the decimal point. So the p-value is 0.0000538. So 1, 2, 3, 4 zeros and then 538. This is very small. Assuming that we have a, let's say, a 1% level of significance or even 5% level of significance, then this p-value is less than that alpha, and therefore we do have an R that is significant. We have evidence to that indicate that there is a linear correlation between the two variables. So, is there a linear relationship between variables? and the sample data supports the claim that there is a linear relationship between the two variables. The variables are the year and the CPI. Find the coefficient of determination and interpret it. So we ask Excel to always show us R squared. R squared is 0.7558, or usually stated as a percent, 75.6%. And the interpretation of the R squared is that 75.6% of the variation in the Y variable, which is the CPI, is explained by the variation in the X variable, which is the time in years, based on the line of best fit. The next question is if there are any outliers. So if there are any outliers, we have to find the sum of the squared errors or the sum of the squared residuals. From that, we want to find the standard deviation. Then we want to find 2 times the standard deviation. And then we want to compare the residuals to 2 times the standard deviation. And we will do that in Excel. So we want to find the residuals, which are equal to the real Y minus the Y hat. And then we want those residuals to be squared. You can check if you have done a good job by adding the residuals and trying to verify that you have a value very close to 0. And I do. I mean, the rounding here will give me a negative 1.6. I would have liked it to be a little better, but when I just copy the A and B from Excel, they have already been rounded. So error squared, I want to square every residual that I found, and therefore I want to now add the squared errors to find the standard deviation. The standard deviation equals to the square root of the sum of the squared errors divided by n minus 2. And let's put this in parentheses. I have actually calculated n here. It would have been nice if I had just calculated the degrees of freedom so that I could use them above, and also I could use them here. This is my standard deviation, about 25.4, and 2 standard deviations will be 2 times this 25.4, and it comes out to be 50.766. So S is about 25.4 when rounded. 2 times standard deviation is 50.766 approximately when it's rounded. So then I want to look and see if there is any point that has a residual, I'm sorry, not a Y hat, a residual that is more than this 50.7 or less than a negative 50.7. And I do have a 47, but it's not too far to be considered an outlier. It is close to 50.7, but not more than that. It is actually less than that. So that seems to be the point that is the farthest away, but it is not considered an outlier. So all the residuals are less than 2 standard deviations for all points. So I have no outliers. Remember that for the glossary for this last unit of our statistics course, we talked about outliers in the case of linear correlation and also about influential points that are points with an X value far away from the rest of the cluster of the data.